Well, now we're going to do next question is set of questions, series of questions are challenging problems on exponents and surds. Okay. Question 1 here says show that square root of 3 raised to the power of -2 x plus 4 times 3 to the power of 1 minus x equal to 13 over 3 over x. Now, okay. I will first transform these square root of 3 again. I prefer to write it in terms of in exponential form. Okay, so this equation will be then number 1, it will be like 3 raised to the power of, okay, I'll write it this way. This will be the power of -2x plus 4 times equal to I'll write this way. Okay, over here, 3 square root of 3 can be written as 3 to the power of half. Okay, and then 4 times 3 to the power of 1 minus x can be written as 3 to the power of 1 times 3 to the negative x. Okay, and then it was 13 there over 3x, so we can times here by 3 to the power of -x. Now, over here, we can combine these exponents. Okay, I put the law of exponent that says, you know, if you have like a to the m raised to the n, this is equal to a to the m times n. Times n. Okay, so we times the exponent there. That makes 3 to the power of -x. Okay, plus 4 times 3, because 3 to the power of 1 is just 3. 4 times 3 is 12. 3 to the -x equal to 13 times 3 to the -x. Now, notice that we have 3 to the -x here, 3 to the -x, 2 to the -x. We can call it, we can give it a name, we can call it a variable like n. Okay, let's say this is n. N. This will be like n plus 12n equal to 13n. That's true because n plus 12n makes 13n. Therefore, this will be 13 3 to the -x equal to 13 3 to the -x. So we prove that the left-hand side equal to the right-hand side. Thank you. Now for question 2, the question says that show that this expression here is just equal to square root of 3. So meaning more work to do, there are more work to do on the left-hand side. Okay, I will first transform it. I prefer to write the numbers in terms of the digits in terms of their prime factors. So instead of me writing 9 there, I was just gonna say this to the power of x plus 1 minus 6 times 3 to the power of 2x all over square root of 3 to the power of 4x plus 1 all equal to square root of 3. I can write it also in terms of its prime factor. So now this will be like 3 squared minus 6 is some as 6 times, I mean 3 times 2. 3 times 2. Okay, it was 3 times 2, yes. And then there it's 3 to the power of a half. And then that's 3 to the power of a half also. Then if we apply this, the law of exponent, we times exponent here, and then we times this exponent also. The law of exponent says a to the m raised to the n is the same thing as a to the mn. Okay, so this will be what 3 to the 2x plus 2 minus we can just say 3 times 2 times 3 to the 2x all over that makes 3 to the 2x plus a half. Okay, equal to 3 to the power of a half. Then we can separate also this. Okay, over here we can make we can break 3 to the 2x plus 2 we can make it 3 to the 2x times 3 squared minus I don't, okay, 3 times 2 times 3 to the 2x all over 3 to the 2x times 3 to the power of a half equal to 3 to the power of a half. Now, note that we have like 3 to the 2x and 3 to the 2x there. We can take it as a common factor, okay? So this will be now 3 to the 2x for the common factor. This addition is going to be 3 to the 2x times 3 to the half equal to 3 to the power of a half. Now the factor there is going to be 9 minus 6, okay? So we can simplify this and that. And then what we have, like 9 minus 6 is just 3. And then that makes 3 over 3 to the half, okay? Equal to 3 to the power of half. Now, there, there's an invisible exponent here of 1. In cases like this, when the bases are common, we can just subtract, okay, the bases. So this will make just 3 minus a half, 2 to the power of 1 minus a half, equal to 3 to the power of a half. This makes 3 to the power of a half equal to 3 to the power of a half. So left hand side is equal to right hand side. Then question 3 says that show that this expression here on the left hand side is equal to the expression on the right hand side. Now let's prove it. We can transform, rewrite, okay? What is the square root of this? We can write it in the exponential form. Note that the nth root, okay, it is said that the nth root of a to the power of m equal to a to the m over n. So over here, when you don't see any indices, we call the indices the n, understand that it's just 2. So we can rewrite it in exponential form as x to the power of 5 over 2 minus x to the power of 3 over 2 all over x, all raised to the power of 2. And then we need to prove that this is equal to that. And then we have a condition here that says that x is greater than 0. Now, what can we do here? I can rewrite it as x to the power of a half or to the power of 2 instead of rewriting 5 over 2. Or I can say, okay, 5 over 2 is 2.5, okay? So it's like 2.5 minus sum also as 3 over 2 is also 1.5, and all is over x raised to the power of 2. Now 2.5 is like 2 plus a half, which can be written as 2 plus a half. So we can write like x to the power of 2 multiplied by, okay, let's just do all the steps. It's like 2 plus a half, okay, minus x to the power of 1 plus a half all over x. To the power of 2. So this can be written as x to the power of 2 multiplied by x to the power of a half minus x multiplied by x to the power of a half over x raised to the power of 2. Then over there, we can take this for common factor. Okay, we take that one for the common factor. This will be, okay, we can take that one is a common factor. And then notice we also have x over here. There are two x's and then one x there, so I can take also x as a common factor. So the common factor can be x and then x to the power of a half, and then all over x to the power of 2. Okay, what should be in the brackets is going to be like x plus 1 then. Okay, if we take x multiplied by x to the power of a half for common factor, you see, 1x will remain here, and then there is always an invisible 1 there. So let me explain here. X squared is like x times x, and then over here it's like there's an invisible 1 there. If I take 1x with this x out, and then I take this with that out, so over here there will remain 1x, and then there the invisible 1 in green here. Okay, then we can simplify this expression. We can simplify x with x, and then this to the power of 2 equal to what? It means x to the power of a half is now to the power of 2, and x plus 1 is also to the power of 2. Now let's see. This is, we can simplify the exponents here, and then this is just x plus 1 to the power of 2, which is exactly the expression we had here on the right hand side. So we can say proven. Okay. Well, we have another question here. The question says that calculate this without the use of a calculator. Okay. We can write it's 4 multiplied by square root of 2. We can write it in exponential form. Okay, this raised to the power of 3. And 8 also, we can write it in its exponential form. So square root of 2 is like 2 to the power of a half, and 8 is 2 to the power of 3. Okay. Now this will be equal to okay, 4 also can be written as 2 squared. So 2 squared. Now that's let's first simplify. We can simplify this 3 with that 3, and then this will be like 2 to the power of 2 multiplied by 2 to the power of 3 over 2 multiplied by 2 to the power of 2. Okay. Now that we have some bases, we can just add exponents. We can just write 1, 2, and then to the power of 2 plus 3 over 2 plus 2. And then this will make 2 to the, it can be, this will make 2, 4, 5.5. All right. Let me double check if I make it. Yeah, it's 5.5. Okay, good. Question 5 says, excuse me, given P of x is this expression. Now, if x is equal to 2011, then P is equal to these questions, these alternatives. Okay, questions like this, it's always important to try simplify the question, the problem without before substituting the value of x here. Okay, so in this case we will do like P will be equal to, this is 5x, 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 5x. It's a sum. We don't have a rule for this. What you can do, we count 1, 2, 3, 4, 5. So it's 5 to the x, 5 plus 5 to the x plus 5 to the x. So this means 5 times 5 to the x, excuse me, all over 5 to the x to the power of 5 is like 5 to the x times 5 to the x. Okay, then we can simplify 5 to the x's, and then this will be, no, that's not 5 to the x, but 5 to the 1. To the 5, I mean. Okay, we simplify the 5 to the x's, and then we have left with 5 over 5 to the x to the 5. Now, this is like 5 to the 1. Okay, so this can be written as 5 to the 1 multiplied by 5 to the negative 5, which is 5 to the negative, okay, 5 to the 1 minus 5, which is 5 to the negative 4. So the correct answer is alternative 3. Excuse me. Okay. Uh, um, another question here, question X. Question 6, that is solve for X, 2 to the X minus square root of 2 to the power of X plus 8 plus 64. Okay, what can we do here? I prefer to write all this in terms of the prime factors. So this will be like 2 to the X minus, this is like 2 to the X plus 8 plus 64 is like 2 to the 6 equals 0. Now, square root of 2 will be 2 to the power of a half. Now, this will be 2 to the X minus 2 to the X over 2 plus 4 plus 2 to the 6. Then, what can we do here? We can split this into 2 to the X minus 2. I prefer, okay, 2 to the X over 2 multiplied by 2 to the 4 plus 2 to the 6 equal to 0. Then we have a form of a trinomial here. Maybe you don't see it yet, but let me prove it to you. The fact that this exponent is a fraction, it's over 2. We can write it, we can write the equation as follow. We can write it like, instead of writing 2 to the X, I want to write it in terms of 2 to the X over 2. So 2 to the X over 2 multiplied by 2 to the 4. Okay, 2 to the 4 is 16. I prefer to keep it like that, 16. So 16 multiplied by 2 to the X over 2 plus leave it 64. Okay, so over here, instead of me writing 2 to the X, I am going to write 2 to the X over 2. I know that if I raise it to the power of 2, okay, the exponent here will just be X. But I prefer to write X to the X over 2 to have something similar to that. Now, note that within the bracket, we have like 2 to the X, and then there 2 to the, 2 to the X over 2 to the X over 2. We can call it a name like a variable, like N. Now, this will make a quadratic trinomial. So this will be like N squared minus 16N plus 64 equals 0. Then we can factorize this, okay? We can factorize equals 0. Now, when I look at the number that we have here, 64, let me list all the factors of 64 somewhere. There are 1 and 64, 2 and 32, not 3, 4 and 16, yes, and not 5, not 6 either, 7, no, um, um, 8 and 8, yes. Yeah, and then we can stop there. Now I'm looking for the couple that will make a sum which is equal to negative 16 here. And then we can get negative 16 if we use negative 8 and negative 8 there, because negative 8 minus 8 makes negative 16, and negative 8 times negative 8 makes positive 64. So over here it's negative 8, there negative 8. So in a situation like this, when this is common, we can just say n equal to 8, or we can just say n minus 8 equals 0, or not or, but which means n equal 8. But now, initially, we're not looking for n, we're looking for x. So I can substitute the value of n, which was 2x, equal to 8. 8, which means 2 to the x equal to 8 is 2 to the 3. And then same basis, what we do, we chop the basis, and then we equate the exponent. X is equal to 3. So the value of x is 3. Okay. Actually, not exactly that, because it's not, it was x to the power of x over 2. So not to the power of x, but to the power of x over 2. It was that initially. So this would be 2 to the x over 2 equal to 2 to the 3. Okay, and then we're gonna drop the basis as we said, and then we'll have x over 2 equal to 3. Now to get the value of x, we times by 2 both sides, and then this is equal to 6. That's the real value of x. Thank you. Well, we have another interesting question here. Question 7 says, without the use of a calculator, determine which number is the largest. Okay, and then here we have question A that says 3 to the power of 360 or 2 to the power of 540. Now, how can we do that then? We look at the bases are prime numbers. Okay, but the exponents are not, of course. But what can we do? This is 360, that's 540. What I'm thinking of is what the fact that when I look at these numbers can be divided by they have a common factor. They can be divided by 90. Okay, 360 and 540. I can divide both by 90. Let me write them down here. The exponents, only the exponent, 360 and 540. I say divide by 90 because when I cover the zeros, if we cover the zeros, we have like 360. I know 36 is a multiple of 9. 54 is also a multiple of 9. Okay, this is 9 times 4. Okay, and then that is 6 times 4. So therefore, this is like I can say this part here is 90 times 4, and this other part is 90 times 6. Okay, but now this if I want to check this out, well, next question says, without the use of a calculator, determine which number is the largest. A, 3 to the 360 or 2 to the 540. B, fifth root of 16 or third root of 5. Well, this is quite an interesting problem here. Let's start with A. 3 to the 360, what can we do here? Okay, I would like you to consider the exponents here, to look at exponents. And then the fact that the bases are not common, we need to compare the two. Okay, I'm gonna write it this way. 3 to the 360, 2 to the 540. We can reduce the exponent because it's quite a lot, it's large, okay? So I can write 3 to the 360 as 3 to the power of, let's say to the power of, or we can take to the power of 10, okay? To the power of 10, or to the power of 36. No, this will not work. Instead, because I want to have like some exponents, okay? So instead I can say, what is the common multiple of 360 and 540? Cover the zeros. Consider 36 and 54. What is the common factor? You know that it's 9. 9 gets into any common factor. It cannot be, it mustn't be just the highest common factor. I can say 9 because 9 gets into 36 and then gets into 54. So if I say 9, for instance, I will say this will be reduced to 3 to the power of or even 90, okay, because you have 0 there. So one of the highest common factor is 90. So I would like the exponent 90 to be outside, so I can write 3 to the power of 4, okay, to the power of 90. And then there it's going to be 2 to the power of 6 to the power of 90. Okay, note that all this makes 360, that makes 540, okay, the product. If we do 4 times 90 makes 360. 6 times 90, it makes 540. Okay, then the fact that here the exponents are common, we're comparing these two. Okay, we need to find what sign we're gonna write here. Because they're common, we can just cancel these because we're comparing them, and then we have left with 3 to the power 4 compared to 2 to the power 6. Now this is easier now to calculate because we know the value of 3 to the power 4. You know, it's 81. Or if you're sure, do 3 times 3 times 3 times 3, we're gonna get 81, and 2 to the power 6 also is 64. Then we can compare, and then we'll say that we say 81 is greater than 360. 81 is greater than 64. Therefore, 3 to the power of 60, 360, I mean, is greater than 2 to the power of 540. Let me say it over again. First, I tried to find the common factor of 360 and 540. Okay, I think I took the highest common factor here, yes, which was 90. Now I write it like, instead of writing 3 to the power of 360, I write 2 to the power of 4 or to the power of 90. Same also here. Instead of writing 2 to the power of 540, I write 2 to the power of 6 to the power of 90. Knowing that I can cross, because I'm trying to I'm looking for what symbol to place here between the two. Okay, so we can drop the exponent 90 like that. We need to compare down 3 to the 4, 2 to the 6. Now we can see that here this is just 81 and that's 64. Because 81 is more than 64, therefore 3 to the 360 will be greater than 240. Okay, 2 to the 540. Now let's do B. Square root of 16, fifth root of 16 can be written as 16 is 2 to the power of 4, and then cube root of 5 there. Now this can be written as 2 to the power of 4 over 5, and there it's 5 to the 1 over 3. Okay, we can write this with a common denominator. Okay, the denominator is not common. We need to make the denominator common. I know to do that, we will times here by 3 over 3, and there we times by 5 over 5. Okay, because the highest common factor is 15. Okay, I'll times here by 3, and I times also the denominator by 3. Here, I'll times by 5, times by 5. So this will be 2 to the power of 12 over 15. We need to compare that with 5 to the 5 over 15. Now that we have a common denominator, this can be written as 2 to the power of 12 to the power of 1 over 15, because, and there also it's going to be like 5 to the 5 to the power of 1 over 15. Okay, remember this is the same as that. Okay, and I think this exponent here is the same as that one, and then this one will be the same as that one. Okay, so now the exponent, down the exponent are common, we can just drop this and then compare 2 to the 12 with 5 to the 5. Now I think I will know what 2 to the 12 is. It's going to be 4096, but you may not get it that way. What you can do, you can break it up into smaller exponents. You can make it 2 to the 6 times 2 to the 6, or you can make it even 2 to the 10 times 2 to the 2. Compare that to 5. 5 to the 5 is like 5 to the 4 times 5 to the 1. Okay, because I know 2 to the 10, what 2 to the 10 is. Someone else can say 2 to the 5 to get it 32, and another 2 to the 5 and compare. Because this one is 124 multiplied by 4, and then this is 625, 5 to the 5 multiplied by 5. Obviously, 1024 multiplied by 4 will be greater than 625, because this will give me something in the 3000s. Okay, 3000, actually it's going to be 3070. Okay, let's just do it This makes 4096. That makes 4096. And then this one will be 625 times 5 would be 3075. 3070. No, 4,000 already. Okay, let me double check. I think this, no, 6 times 9 makes 3,000. 25 times 5 makes 125. So 3125. Yes, this is 3125. So this is greater than that. Okay. Or you can use smaller numbers, exponents, 2 to the 12 times, I say 2 to the 12 compared to 5 to the 5. You may do 2 to the 12 can be 2 to the 4 times 2 to the 4, I don't know, or 2 to the 6 times 2 to the 6. And then, or maybe let's say 2 to the 6 times, you can do it like 2 to the 4 times 2 to the 4 times 2 to the 4. All this would make 2 to the 12 because 4 plus 4 plus 4 makes 8. And then you compare that with 5 to the 5, you'll see that the solution will be the same. Okay, so you can use small exponents, but I use 2 to the 10 because I know this is 1024. Okay, multiply by 2 to the 2, which is 4, and then this makes 4096 is greater than that. Okay, thank you. Well, question 8 says, excuse me, I simplify this expression given that n is a natural number and n is a multiple greater than or equal to 2. So in this case, now write like we have the nth roots of this expression. 4 can be written as, in terms of its prime factor, as 2 squared. So that's like 4 to the 2n multiplied by that also to the n plus 1 multiplied by 8. Now this will be written as 4 will be 2 squared, and then 1 over 8 is 8 is 2 to the power 3, so we can write like 2 to the negative 3 because it's at the denominator, and then this 8 here can be written also as 2 to the power 3. Okay, then within the roots we can write, within the nth roots we can write 2 to the 4n, okay, multiplied by 2 to the negative 3n plus, careful here, it's negative 3 times n and negative 3 times positive 1. So negative 3n minus 3 times 2 to the 3. Okay, this is the nth root. Now that we have a common basis in the root, we have 2 there, 2 there, and 2 there. We can just write 1, 2. Okay, so like only 1, 2 to the power of, you can simplify the exponent. Okay, 4 minus 3 plus 3 would be just 4. So we're like a 4 minus 3n. Okay. Then this can be written as this can be written as 2 to the 4 minus 3n over n. Okay. Excuse me, I think I've got here in the bracket here, it's 4n minus 3n. It's 4n, not 4, but 4n minus 3n, just n. So that's n. And then minus 3 plus 3 will be 0. So we have 2 to the power of n. Then we can simplify this root with n, and the answer is just 2. Okay? Because we can also say 2 to the n over n, which is equal to 2 to the 1, which is 2. Thank you. Question said calculate this, leave the answer in a positive exponential form. All right. Now, we can write it as I'll leave here two. Now look at what is the smallest exponent here. The smallest exponent is it's not this one, because 4 to the power of 1000 can be written as okay, I'm gonna rewrite this. It's gonna be like 2 to the power of 2013 minus 6 times 2 to the power of 2011 all over 10, and then that's gonna be like 2 squared. So this will be then 2 to the power of 2013 minus 6 times 2 to the 2011 all over 2 to the 2020. Okay, it's gonna be that. Then if I look at the smallest exponent here is this one, so I can write those I can write each term here to the power of 2010. So this can be like 2 to the 2 times 2000, 2 to the power of 2011. I meant to say 11. I can write all in terms of 2 to the power 2011. So it's gonna be, this product here makes 2013, okay, because you add exponents. Minus the 6 times 2 to the 2011, and at the denominator here can be written as 2 to the 2011 multiplied by 2 to the 2 to the 9. Knowing 9, yes, knowing that if I combine here, I'll get 2020 here. Then we can take 2011 for common factor, because it is, and then this will be 2 to the 2011 for common factor all over 2 to the 2011 multiplied by 2 to the power of 9, and that's going to be like 2 squared is 4 minus 6. Then over here we can simplify this and that, and then 4 minus 6 just negative 2 over 2 to the power of 9. Now this can be written as negative 2 times 2 to the negative 9, because the question says leave answer in exponential form. Okay, so we can then or maybe wait, negative 2 over 2 to the power of 9 can be written as like negative 2 over 2 to the power of 9. Okay, and then this will be like it's like negative 2 over 2 multiplied by 2 to the 8, because it's 2 to the 1 there. We can simplify then also these 2 and that one, and then the answer will be negative 1 over 2 to the power of 8. We can write it this way, or we can also say negative 2 to the power of negative 8. Both are exponential formulas. Thank you. Well, question 10 says, show that this expression equal to that expression. Hence, determine the sum of the digits. Okay, this digit. Quite interesting. So we have 2 to the 2011 multiplied by 5 to the 2007. We need to prove that this is 1,6 multiplied by 2 multiplied by 10 to the power of 2008. Okay, the bases here are different, so we cannot say 2 times 5. We can't do that. What can we do instead? Over here we can transform. Okay, 1,6 here can be written as 16 over 10. Okay, multiplied by 2 to the power of 2000, not 2 but 10 to the power of 2008. Now this 10 here can be, we can move the 10 at the numerator. That makes 16 times 10 to the 2008 multiplied by 10 to the negative 1. Now this can be like 16 multiplied by 2000 not 2000, sorry, 2 to the power of 2008 minus 1, because here we've combined, it's going to be to the power of 2007. Excuse me, I keep writing 2 instead of 10. It's going to be, we combine the exponents, it's going to be 10 to the power of 2007 now. Now, equal to 16 can be written in terms of its exponential form, it's 2 to the power of 4. And then type 10 also can be written in terms of exponential form. I mean, its prime factor. It's like 2 times 5 to the power of 2007 now. Okay. Now the 2007, the power of 2007 is for both 2 and 5. So 2 to the 2007 multiplied by 5 to the 2007. Now over here, the bases are common, so we can combine the exponents. That makes 2 to the 2011 multiplied by 5 to the 2007. So we can prove that left-hand side equal to right-hand side, because this part here is what we had on the left-hand side. Thank you. Now, question 11 says write each in exponential form. Okay, so let's start over here. T1 will be root x will be x to the half. Okay, that was 1. 2, root x times root x. Okay, I keep it as x there, and then root x will be x to the power of half. So the product here. So this will make x to the power of 3 over 2. Now, which is now x to the power of 3 over 2 again, because I'm applying this law of exponent. So 3 over 2. There is an invisible indices over here, and then you know, this is just x to the power of 3 over 4. Okay, because the numerator is a fraction. 3 over 2, the numerator is 2, so it's going to be x to the power of 3 over 4. We times these 2. Okay. Question 3. It's going to be square root of, that makes x. Now, this x within this root will make x to the power of a half. The other it is also, there's another root within the root, it's that. So let's write it like this along. So we have this x here within the root, and then there's another root which has, okay, let me write this way. There's another root within the root, which will be this x will remain x, and that one will be x to the power of a half. Correct. Now we can combine these two, because it has this one has an invisible exponent of 1, so that makes x to the power of 3 over 2. When we do 1 plus a half is 3 over 2. So this will be square root of, we have this x there, square root of x to the power of 3 over 2. Now we did prove already that this square root of that equal to 3 over 4. Okay, x to the 3 over 4. So I can just write there square root of x times x to the 3 over 4. Now we can combine these again. Okay, because there's an invisible exponent 1 there, we can do 1 plus 3/4 is equal to 7 over 4. So that makes x to the 7 over 4. And applying this law, it's going to be x to the 7 over 4 all over 2, which makes x to the 7 over 8. Okay. And then question 4 is, actually we can just use this one and then to make them 4. okay, term 4 or question 4, T4 will be equal to, okay, note that these whole parts this whole part here, not, I mean, this part here is the same as the one we got in term 3, okay? So we can just say square root of x multiplied by x to the 7 over 8, okay? Again, this will be square root of x to the power of, we're going to add the exponent here. If you add the exponent, it's going to be 15 over 8. And then this will be x to the 15. Okay, let me write it over here because of space. Over 8. That will be x to the power of 15 over 8 all over 2. And that means x to the power of 15 over 16. That was question A. And then question B says identify the pattern and then determine these term 10, term Tn, okay, T10, Tn, and then T100, and also T infinite. Now let's see the pattern here. The exponent here is a half. Here the exponent is 3 over 4, and then that's going to be 7 over 8. And then there is 15 over 16. Now when I look at I was saying when I look at here, it's the exponent is a half, this 3 over 4, this 7 over 8, this 15 over 16. Let's look at the numerator. The numerator is like we plus 2 to get 3, and then there we plus 4 to get 7, and then we plus 8 to get 15. So we're plusing a multiple of 2 of the previous term, like because the previous term was 1, I'm going to add 1 times 2 to 1. Okay, so let me write this way. The general form can be, I can say Tn will be like x to the power of, the first term is 1, okay, and then we're going to plus 2 times 2 times 1 to it at the numerator, okay, let's say n, yeah, it's n, and then the first term is n, yeah, 2 times n. At the denominator, it must be it's like the numerator is 2, 4, 8, and then 16. So this is like 2 to the power of n. 2 to the power of n. Okay, yes. So if n is 1, for instance, if n is 0, the initial, okay, this will be well, we have another question here, question 11. The question says that write each, excuse me, write each term in exponential form. Okay, they give here term 1, term 2, term 3, term 4, and then B says identify a pattern and then determine the value. All right. Let's look at the question. Term 1 in exponential form. T1 will be equal to x to the power of a half. Okay, in exponential form, I use this formula. The nth root of a to the power of m equal to a to the power of m over n. And then term 2 will be, you see, this is square root of x of the square root of x. Now, square root of x here, we already find it's x to the power of a half. So I'm gonna write here, it's gonna be square root of x multiplied by x to the power of a half. Okay, and then this will be square root of what? Because there is an invisible one here, we're going to add the exponent. That makes x to the power of 3 over 2, because 1 plus a half makes 3 over 2. Maybe I can just write it a bit like that. 3 over 2. I guess it's visible. If it's not, let me make it a little bit bigger. I was saying there is an invisible one here, and then this will be square root of, we add the exponents, okay? It's going to be x to the power of 3 over 2. Then in exponential form, this means we're going to write x to the power of 3 over 2 all over 2. You know, when we have this type of fraction, because the numerator is a fraction, and then the denominator is just an integer, okay? So we can times 2 and 2, and then we say this is just x to the power of 3 over 4. Then term 3. Term 3 is a square root of x, square root of x, square root of x. So now note that this part here is the same as term 2. So we can write it as so square root of x multiplied by x to the power of 3 over 4, 3/4. Okay. So again, over here there is an invisible power, which is 1, and then term 3 will be equal to we're going to add the exponent, okay? So 1 plus 3/4 is equal to 7/4. X to the power 7/4. So now it's going to be 7 to the power 7 over 4. Okay, x to the power 7 over 4. Then to write this in exponential form, we can write x to the power 7 over 4 all to the power of 2, and then we will times the denominator with the main denominator. So this is going to be x to the power of 7 over 8. Okay, so term 4 will be, let's see, term 4 is basically everything here is what is term 3. Okay, all this here is just term 3. Like here, here it was term 2, and then there this part was just term 1. So term 4 will be then square root of x multiplied by x to the power of 7 over 8. Now again, there's an invisible power there, which is 1, and then term 4 will be square root of, so we're going to add the exponent, okay? 1 plus 7 over 8 will be 15 over 8. 15 over 8. Then we can write it. This is going to be x to the power of 15 over 8 all over 2, which is x to the power of 15 over 16. So this was term 1, and that's term 2, term 3, and term 4. Okay. Now question B says identify a pattern and then determine. So if you need to see the pattern here is how can I write the pattern? How can we do question B here when they say identify the pattern and then determine? Okay. Oh, all right, I see. We need to identify the pattern here. We will notice that what is in the bracket here, as I was saying, square root of x. Okay, square root of x there is in the root, and square root of x in the root. The square root of all this, like it basically. Let me write it over here. we have here square root of x, and then it is again square root of x, square root of x, and then term 2, the whole of term 2, okay, the whole of term 1 was here in term 2, okay, in the root x term 1, and then root x term 2, and then root x term 3, okay. So we can write this pattern as square root of x multiplied by term, the previous term, okay, the previous term can be written as n minus 1, okay. It's one way how we can write the pattern. If I look at these term 1, term 2, term 3, term 4, we can write it like that. Or we can write it, okay, first of all, I said over here that this pattern can be written as square root of x multiplied by term 1 minus 1, term n minus 1. Term n minus 1 simply means the previous term, okay? So if this is term 2, if Tn here is like term 2, in there it's going to be n minus 1, so 2 minus 1. That's why we got term 1 here. So this is term 3. Inside here, what's here is going to be 3 minus 1, which is term 2. And then same also here, term 4, it's going to be term 4 minus 1, so that makes term 3. Then we can also write it this other way. If I consider the pattern, term 1 here is, let me write it over here. Term 1, we find it x to the power of a half. Now let's look at how it behaves. If I say the numerator is 1, 3, 7, and 15, the denominator is 2, 4, 8, and 16. Okay, for the denominator, it's quite easier to see that they're all powers of 2, like 2, and then 2 squared 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, okay? Now, but for the numerator then, it's just like 1 less than what's at the denominator, okay? 1 over 2, 3 over 4, 7 over 8, 15 over 16. So we can write this term as Tn, I said Tn was this, but we can write Tn as x, okay, to the power of what? The denominator is going to be 2 to the power of n, okay? And the numerator is going to be 2 to the power of n minus 1. So this is actually the general form, the general term for this pattern, okay? Then the question continues and says identify then T1, T2, T3, and T4. So now we can work out T1. That was B. So now T1 will be obvious. Let's say identify T10. Sorry, T10, not T10. I will substitute 10 wherever I have n. Okay. So T10 will be x to the power of 2 n minus 1 over 2 over 2 to the power of n. So instead of me writing n, I'm going to substitute that by 10. Sorry, I didn't write it well. I need space. Let me write it like this. I'll move. Okay. So I can say T10. T10 will be I'll write x, okay, and the denominator it's 2 to the power of n, okay, and the numerator is 2 to the power of n minus 1, okay. I'm referring to this formula. Now T10, it means wherever we have n, we substitute by 10. So it's going to be 2 to the power of 10 here and 2 to the power of 10 there. So this is T10, which will be T10 will be equal to x to the power of the denominator 2 to the power of 10 is 1024. Yeah, 1024 over 1024 minus 1, 1023. That's going to be T10. And then what else? We want Tn. I wrote Tn already when I find the formula. Tn is x to the power of 2 to the n minus 1 over 2 to the n, okay? And then t to the infinite, t100, okay? It's going to be the same thing. t100, I'll write x there, 2 at the to the power of 2 to the power of n all over 2 to the power of n minus 1. So I sub 100 instead of n. So this, I'll leave it like that because it's a huge number. That's t100. And then t to the infinite, infinite, this symbol stands for infinite. Oof. This, we need to be careful over here. On the right, it's going to be x to the power of 2, no, 2 to the power of n, all under 2 to the power of n minus 1. So I can substitute there. So we have t to the infinite, meaning we're going to substitute infinite there also. And it's going to be hard to do it now. Okay, I prefer to do this way. Initially Tn was x to the power of 2 to the n under 2 to the power, the numerator was 2 to the n minus 1, okay? Let's first simplify this. We can write in the simpler form. This will be, you know, we can separate the fraction. It will be x to the power of 2n over 2n minus 1 over 2n, okay? So over here, we can simplify the fraction, and then this makes x to the power of 1, or just x, multiplied by x to the power of -1 over 2 to the n. Now, we can simplify this way. Okay, so now if we want to work out t to the infinite, then 2 to the infinite, it means we're going to substitute where we have n by infinite. So that makes x to the power of or maybe let's do this way. Okay, let's keep on simplifying this. The negative exponent here means it is at the denominator, so this will be 1. It's gonna be like 1 over x to the 2n. Okay, so oh no, I misread. It's not really that. Actually, yeah, I can work it out from there. Okay, this is what we can do. T to the infinite, I can solve it from here. It will be x from x times x to the -1 over 2 to the power of infinite. So I'll substitute there. To the infinite will be infinite there. Now, this will be x multiplied by x to the power. Now, this part here, 2 to the power of infinite. So it means it's going to be infinite also. And then it is a rule that in mathematics, there's a rule that says like any number divided by infinite is just 0. Just imagine a number divided infinitely many times. You have left with nothing. So this makes -0, okay? X to the power of negative here, and then 0. Then 0 doesn't have any negative sign, and that makes x to the power of 0, and x to the power of 0 is just 1. So you have like x times 1, and then the final answer is x. Okay, this part was quite challenging. Let's go over a little bit. When I substituted the value of infinite from the formula that the pattern that we calculated, it was hard to know exactly what the value should be here. But we could manipulate this, okay? I break this fraction, you know, if you have like a plus b over c, this is the same as a over c plus b over c, okay? Plus minus something. So now we split the fraction and then we simplify, we have like an x there and then that. And then this rule says that any number divided by infinite is 0. So when I substitute infinite there, 2 to the power of infinite, it's infinite. So we have like -1 over infinite, which is 0. Okay, I don't really need to write the negative sign here. It's going to be -1 over infinite, which is 0. And then x to the power of 0 is just 1. Okay. This is just 1. And then x times 1 is x. Thank you. Well, we have another question here, question 12, which says solve for x and y if 9 to the power of x plus y equal to 3 to the power of y plus 4 and 5x plus 4y equal to 11. Now, we have like 2 equations which we have to solve simultaneously. Okay, we have I prefer to label my equations. I call this one equation 1 and this one I call it equation 2. From equation 1, we have 9 to the power of x plus y. I prefer to write 9 in terms of its prime factor. Okay, and there it was to the power of y plus 4. Then 9 will be 3 squared in terms of prime factor. And then this makes 3 to the power of 2x, not plus y, but plus 2y, okay, equal to 3 to the y plus 4. Be careful here when we times the exponents. We times 2 times x, 2 times y. Now that we have some basis, we're going to drop the basis and then equate the exponent. So we have like 2x plus 2y equal to y plus 4. Okay. We can solve these equations, make like one variable subject of the other variable. Okay, we have x and y. If I want to work out, let's say y, for instance, it's going to be like 2y here will be equal to, or maybe I need to move 1y, I move this y over and then move the 2x on the other side. Okay, so this will be like 2y minus y equal to -2x plus 4. Now 2y minus y makes y equal to -2x plus 4. Now I express this equation 1 here in terms of y. It's still the same equation, but this time expressed in terms of y. Then remember they say solve for x and y if this and that. Okay, so we can substitute, instead of writing y here, we can substitute by the value -2x plus 4. Now from equation 2, okay, this will be 5x plus 4y equal to 11. Equal to 11. Now I was supposed to write y, but I'm going to substitute y by its value 2x plus 4. Then this will be 5x, positive 4 times -2x makes -8x, 4 times 4 makes positive 16, and then equal to 11. Then I can move the 16 over and do 5x minus 3x makes 3x equal to 11 minus 16. Okay, and then that makes -3x, and then that makes 3x, -3x equal to -5. Now we can get the value of x if we divide by -3 and divide also by -3, and then we get the value of x equal to 5/3. Now that we got the value of x, we can find also the value of y. By substituting then, we know we can substitute over here, over there, but it's better to substitute where we already made y subject of the formula. Now this is the new y from equation 2. Now I can say this 2 here in 1. This will be what? Y equal to negative 2x plus 4. X is 5 over 3. So this will be negative 10 over 3 plus 4. Okay. And then to solve that, we can just say there is an invisible power, denominator there of 1. And then we must times here by 3 and there also by 3 to work it out. That makes now negative 10 over 3 plus 12 over 3. Now that the denominator are common, we can add the numerator. That makes 2 over 3. Therefore, the solution here, the solution will be x equal to 5 over 3 and y is 2 over 3. You can check it out. Okay, if you sub 5 over 3 and then 2 over 3 for x and y respectively, these two will be equal and these two will also be equal. Okay, or another way could be once we make y subject of the formula from equation 1, we can solve this by another technique called elimination. Over here, I use substitution method to find the value of x, but we could also solve it by elimination. What does it mean? Because y was equal to, we got y was equal to negative 2x plus 4, and on the other side, we have like 5x plus 4y equal to 11. Let me double check if I didn't. Yes, 5x plus 4y equal to 11, and then negative 2x plus 4. We could solve this by elimination. How? What does it mean? I'll write here y. Over here, let's even take. Sorry, let's even take from over here as it was. Oh, it doesn't matter. I can take even from here. 2x plus 2y equal to y plus 4. Or no, okay, let's just take this, let's just stick on that. So now we have like y equal to negative 2x plus 4. Over here, I'll move this 5x over, and then it will be like 4y will be equal to negative 5x plus 11. Okay, now we can solve this by elimination. And then I'll see if I need to cancel a variable, like let's say I want to cancel a variable y. I'll times here by 4, for instance. Multiply there by 4. Okay. This will be 4y equal to negative 8x plus 16. And there it will be like 4y equal to negative 5x plus 11. Now we can do our equation. This was equation 1. Equation 1 minus equation 2. We minus the two equations here. 4y minus 4y makes 0 equal to negative 8x minus we make it plus. So that means negative 3x. And then 16 minus 11 makes positive 5. So if I move the negative 3x over, I'll have 3x equal to 5. And then dividing both sides by 3, we have x is equal to 5 over 3. Okay, and then we can substitute again this value in either equation 1 or equation 2, as we did here. We're gonna get the value of y. Okay. Well, now we're going to do question 13. The question says that network marketing is a business model that is quite prevalent in South Africa. in this scheme, people are told how to become rich quickly by using the rules of exponents. Suppose that you get 3 people to sign up in your business. These 2 people in your downline must then each get 3 people to sign up so that they each too each have 3 people in the downline. This process must continue so that your business grows with hundreds of people in your business. How many people will be in your business if the 15th downline, in the 15th downline, what are the problems associated with this kind of business model? All right. Let's say we get like 3 people, okay, in the downline. In my downline, in your downline, you got like 1, 2, 3 people. Okay, there are 3 there, and then each of them must get 3. So let's do it's like 1, 2, and 3. This one also 1, 2, and 3, and that one also 1, 2, and 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So in the second downline, okay, we had like 9 people there, and then the following will be 3 each. I want to do all the the thing I wrote here. I'll say it's gonna be times 3 again. It's gonna be 27. So this is on the first, that's on the second, that's the third, and if you continue like that, you understand that on the 15th it will be 3 to the power of 15, because over here it's like 3 to the power of 1, which is 3 in the first, in my diagram, and then for term 2 I can call it like that. It's going to be 3 to the power of 2, which is 9, and that's 3 to the power of 3, 27. If you continue like that to the 15th, it's going to be 3 to the power of 15. So this will be you're welcome, thank you. So now we can do a 3 raised to the power of 15, and then this is equal to this much. So you can see the number. Thank you. If you do like the videos, please thumbs up and subscribe to the channel. Thank you.